Uh, Hey everyone, so we'll be seeing the example of the multivariate linear regression. So we'll be seeing how do we do it in the uh, in our own row way, and we'll be like in the doing in the programming sense. So like we'll be seeing an example that how do we do. So we have like two data here. Okay, so we have two independent variable which is this and this. These are independent. This is dependent. This is dependent, dependent, and this is independent, and these are independent. Okay, so we have dependent and these two are independent variable. Now what we do in the multivariate linear regression, so we have a cost function. Okay, so we have a cost function as we have seen in the previous one in the linear regression. So we have a cost function. So we have a cost function which has like lot of like MSC, RMSC, and MAE. These are just like forms of the cost function. So in the MSC, it is mean squared error. It is mean squared error. Error. This is the root mean square error. So what do we do actually? That it is same as mean square error, but what do we do? That we use like root on it, so we can get like the direct value of it. So what we take? It is root mean squared error. Root mean squared error, and this is mean absolute error. Okay, mean absolute error, mean absolute error. So these are all like we can use it in multilinear regression also, like multiple linear regression also, sorry, multivariate linear regression also. But the computational cost, the it is so expensive, it is so expensive, and the computational cost is very high. So what do we do actually? Just we get away. So we found a way which reduces our expenditure of the computational power, because it takes a lot of computational power to calculate things. So what we have done, that we found a simpler way which calculates the same thing but in a less time and in a very less expenditure. Okay. So what we have done here is like we got some example which are like these. Okay. So we have like sort of like data which is like raw data, like I've took it in a way like as I liked. So what will you do? That as we know that how do we get uh, our the hypothesis, the predicted value. So what do we do? That we multiply this with the theta. Okay, with the theta. What do we do? That we multiply with the theta. Theta is nothing but the parameters or the coefficient what we had. So let's take the theta vector. Okay, theta vector, in which let's suppose we have theta 1, theta 0, theta 1, theta 2. Okay, so now we need to take some data set also, which is like, so now we need to arrange this in a matrix form. Okay, so how will we arrange this? We'll take these x1 and x2 in the form of matrix. So this will be like, this is our x1, this is our x2, and we'll put it like 1 2 3 4, right? 2 3 0 and 2. Okay, so we have this. Now additionally what we'll do, that we will add another column of 1. Okay, why? Because we have theta 0 also. And what is the theta 0? Theta 0 is nothing, theta 0 is like one of the parameters. So if you want to theta 0 to be fit in, then what will we do? That we will use these 1 to add this. Okay, so how will you do it? We'll see. Okay, so now we have our matrix like this, right? We have our matrix like this. Now we have our theta 0, theta with vector also. Okay, theta 1, theta 2. Got it? Got it? Chalo. We'll do with this, we with this, and this will do with this. Okay, so we know how do we multiply it. Okay, we know how do we multiply it. This is our, okay, x, and this is our theta. We'll multiply it. Now we have this. Okay, so let me write it here. So we have this theta of 0 y by 2 m is the number of like number of examples, like 1 2 3 4, number of examples which we have. So we'll, it is number of this. And what do we do is that with this we'll multiply with this, and the this is the vector which is our real value. Okay, this is our real value. We'll transpose it, and what will we do that we will add multiply with this. Okay, we'll do with this. So let's do the procedure. What do we have? So first we will add this with this. Okay, but first we need to assign our theta also. Okay, right? Because if we haven't our like theta, then how would we multiply all these things? Because we need some kind of like values to multiply with our these examples. So what we do that let's assign all this theta to 0. Okay, like for the sake of like right now, let's all this 0. Okay, 0 0 0 0. So now what will you do that we will add this, and how will you get it? So let's add it to this, to 0 into 1 plus 0 into 1 plus 2 into 0. Okay, what we got? 0. And for each value we're getting 0. For each value we're getting 0. And our y hat, the vector we're gonna get, it will be the vector we will get, it will be it will be nothing but 0 0 0 0. Okay, it will be nothing but 0 0 0, because like for every, see, for every example, okay, this will with this. Okay, so we have 0, all the beta was 0, all the theta was 0, then we'll having end up with having 0 with this with this 0, with this, with this, and with this, and with this. Okay, so what do we end up having? All the vector with 0. Okay, all end up having with 0. Got it? Okay, got. Now what we have to do right now, that we have to perform this. Okay, we have to perform this, which is our cost function, so yes, let's okay. So now what will we do that we will gonna perform this thing, which is nothing but, so let's see this thing. Okay, which is our this with this. Now y, whatever y vector is, the y real, the value is 4 5 2.56. Okay, it is 4 5 2.56, which is our y vector. Okay, this is our y vector, which is the real value. Now what the value we have got? The value we have got is so what we do with this value we have got is 0 0 minus 4, 0 minus 5, 0 minus 2.5, 0 minus 6. Okay, so what we got? Minus 4, minus 5, minus 2.5, minus 6. Right, right, you getting it? Like, this is what is. Okay, now what will you do? It will be the same with this. Okay, let's see. Okay, see what is being done here. Okay, what is being done here? The value here and the value here is same. Okay, the value here and the value here is same, but the difference in these are that this is transposed. Okay, this is transposed. So what is the transpose in the matrix? Means that changing vector into scalar, or like let's suppose that changing the row into column and columns into row. Okay, so let's suppose if I have to transpose these matrix. Okay, I have to transpose this matrix, like let's do one. Okay, this is our matrix, which is 2 by 2. If we have to transpose it, what will you do it? That we will add, this will come here. Okay, so let's take some different numbers. So 1 2 3 4, for better understanding. 1 2 3 4. What will you do? Let's transpose it. Okay, so let's give the name matrix A, and we have to transpose matrix A. So what will you do? The row will become column, and the column will become row. So how will you do it? It will be 1 by 2, and it will be 3 by 4. This is our transposed matrix. Okay, this is our transposed matrix. Got it? Now what will you do it? That we have transposed our matrix. So what will you do? We will transpose this matrix, and how will you transpose it? So we have 4 row and 1 column, which is 4 into 1. So we will convert into 1 into 4, 1 into 4, which will nothing be but minus 4, minus 5, minus 2.5, minus 6. Okay, this is, and we have gonna this something like minus 4, minus 5, minus 2.5, and minus 6, right? And the number of observations we had, which is 2 into 4, because we have 4. Okay, so now we'll multiply this. Okay, we'll multiply this. So how will we do it? This with this. So we know that how do we multiply it? First we multiply with this, then with this, then with this, and with this, and in the end we add it. We sum it all. Okay, 4 minus 4, it will be 16 plus 25 plus 2, 6.25 plus 36. Okay, this is right now 2, 8. So now what is the sum of this? Okay, so let's add it, and we will end up having like it is a 52, 52 and 25. It will be like 52 plus 25. Okay, so it will be like around 77. Yeah, it is 77 and 6.5. Okay, 6.5 is nothing but like it's 83.2.5. 1 by 8 into 83.25 by 8, 83.25 by 8. So this is end up having, so I'm not going to like calculate right now. This is, it will be the same. Okay, like after calculating we'll have end up having some number which is our cost function. Okay, we'll end up having some number which is our cost function. So if we want like, it will be around like 10. Okay, it will be like around 10 point something. Okay, 10 point something, because like 80 and 83, it is like beyond, so it is beyond from 80. So we'll end up having 10 point some value, and this is big on our cost function, which is like very high. Okay, 10 is very high. 10, if you see, it is very high for this value. So what we do is that we will minimize it for like n numbers of time, like we'll iterate it for n numbers of time until and unless we don't get the number which is like less. Okay, the least number which is like most least number. So we'll do it for the n times until and unless we don't get a least number. Okay, so this is what we do in the multivariate linear regression. I'll be like sharing about the multivariate in the statistical form, which is like applied multivariate statistical analysis or like modeling. I'll be sharing for like next 1 or 2 days, because like I'm learning right now. That is why it's like takes so much time. Like it's take much time and energy and brain. So like it's so eatable. So yeah, this is for today, and I'll be meeting you next time. Peace.